Hi everyone, it's so nice to see those who love physics and math, and today let's talk about extraneous solutions, in which case we can see they happen. Let's take an example. Let me write an equation. Square root of x plus 1 minus 3 is equal to x minus 4. Normal equation, everything looks like fine, everything's okay. Left-hand side could be positive, could be negative. From the very shape we see, we cannot judge, we cannot make it out what's wrong with this, except for the square root. Surely we should state that there is some domain for the whole equation, and it's about the square root. What do we know about the square roots, expressions under them? Basically, that any number, if we're working in real numbers, if we're solving in real numbers, any number under the square root should be not negative, means zero or positive number, okay? That we will write now for the domain. Domain means all possible values of x for this expression, which we can see. Obvious one is just that x should, x plus 1, let's say, should be greater than or equal to 0. That's fine. And x is greater than or equal to negative 1. That's basically the domain we have by evaluating the square root. This part is quite simple and clear. Next, in order to solve this equation, we need to get rid of the radical, and we can do this by moving negative 3 to the right-hand side, or by adding plus 3 to both sides, right? So we can do this operation, plus 3 and plus 3 addition. But just we need to apply it to both sides of equation, that's it. So it would be x minus 1, fine. And then we better square both sides. So now we square both sides. Okay. If we square the square root, it would be just the under square root expression, which is x plus 1. If we square x minus 1, by the algebra expansion formulas, it would be x squared minus 2x plus 1. Now you see that plus 1 and plus 1 we have on both sides of the equation, and if we subtract 1 from both sides, we'll see they would be cancelled out, like this. And our new shape of equation, if we simplify it, is rather simple and nice. X squared minus 2x and minus x is minus 3x is equal to 0. Fine. Best way to solve this equation is what? Is just to factor out x. X is the common factor. X times x minus 3 is equal to 0. Now we use zero product property. Product is equal to 0 if any of factors is equal to 0. Now we make conclusion that either x is equal to 0 or x minus 3 is equal to 0. Both are fine. This would lead us to the solutions of the roots. Okay, x is equal to 0 is first root, already obvious. And x is equal to 3 in this case is the second solution, which is also obvious. But now let's see. Do these solutions have the same value to the original equation? Original equation is like this. X plus 1 minus 3, x minus 4. Actually not. Because if we substitute 0, we would have x plus 1. Let me just mark it like this maybe. if x is equal to 0, then obviously root of 1 is 1, minus 3 is equal to negative 4. And if we add 3 to both sides, we'll get, I'll specially keep the root of 1 so far, okay? It's equal to negative 1. So 1 is equal to negative 1 is not true, but furthermore, we have root on the left-hand side, and we have negative expression on the right-hand side. So here we cannot find any roots. No roots from here. No roots. In real numbers, again. No roots in real numbers. And for x plus 3, you could check it yourselves. Everything would be fine. What is special about solution x is equal to 0? It's kind of solution of the equation because we did everything basically same that we are allowed to do usually, but we've got the solution, which does not fit the original equation shape. Why is that so? Because basically after squaring, we made both sides absolutely positive. Originally, they might not be, but we didn't see it because the shape of the whole equation was like minus 3, minus 4, who knows what's there. That's why when we were talking about domain in the first part of the solution, of the solving process, it was kind of fine. We just figure out that x should be greater than or equal to negative 1. Yeah, and x fits, yeah, like this 0 looks like fits here. So what's wrong with that? But wrong with that is that resultant equation like this is not equivalent to the original equation, because squares would be always positive, non-negative, let's say, yeah? And original equations, left-hand side and right-hand side, could be either positive or negative. We do not know yet. We will dig into this topic furthermore. We'll see how graphs change when we do this kind of operation. But basically, when you have square roots or when you have fractions, sometimes you get extraneous solution. So this one, x is equal to 0, is the extraneous one. It's not the real solution of the equation. It's the solution of this equation. Okay? For this, it's fine. But for the original not. Means it's extraneous. Extraneous. And final solution for us here is just that x is equal to 3. That's the result. That's the true root of this equation. It's the true root. If any questions still are there, please ask. If you have suggestions, what problems to go over, what kind of topic to dig in, what kind of specific problems to discuss, please share. I would be happy to answer. At this point, that's it. Thank you for watching. If you like it, press like, subscribe to the channel. Could have many more soon. And have a nice time in your life. Have great success in your studies. Bye.